So, dear students, let us begin this video on the topic of waves. And when I am saying waves, we will be talking on mechanical waves. So, this is a series of a bit advanced lectures suitable for the students who are in class 11th or 12th, or like the ones who have already studied up to 10th, a little physics can also follow this particular series of lectures. सो आज के टॉपिक में हम जो बात करने वाले हैं वो है मैकेनिकल वेव्स के बारे में, और दूसरा कीपिंग फोकस ऑन योर शॉर्ट अटेंशन स्पैन इन प्रेजेंट टाइम्स. आप लोगों का अटेंशन स्पैन थोड़ा सा कम हो गया है इन प्रेजेंट टाइम्स, विच इज़ अ बिट अनफॉर्चुनेट. सो आई विल बी मेकिंग दिस वीडियो फॉर 15 minutes ड्यूरेशन ओनली. सो 15 minutes के शॉर्ट वीडियोज यू विल बी हैविंग विच यू कैन सी एंड लर्न. So like in the first place, let us define what a wave is. For me, like in particular, it's very difficult to define wave, but still we have to create some definition. So I'll say that wave is nothing but transfer of disturbance from one point to another in a medium. Remember, I am talking of mechanical waves. So transfer of disturbance from one point to another in a medium is called a wave. We can note down this definition. You can say that transfer of energy or disturbance from one point to another. Important point is there is no bulk transport of matter. When we talk about wave travel, just note down there is no bulk transport of matter. So थोड़ा सा आपको मैं इसको क्लियर कर देता हूँ, बिट कंफ्यूजिंग आपको लग रहा होगा. देखिए, there are two ways of transporting energy. फॉर एग्जाम्पल, जब आप एक बॉल को थ्रो करते हो, व्हेन यू थ्रो अ बॉल, तो बॉल कैरीज सम अमाउंट ऑफ काइनेटिक एनर्जी. सो इफ आई हैव थ्रोन बॉल टू सम पर्सन, ही कैचेज इट, देन ही रिसीव्स सम काइनेटिक एनर्जी, यू कैन से, एंड दैट इज बाय वर्च्यू ऑफ द बॉल ट्रेवलिंग फ्रॉम पॉइंट 1 to point 2. यहाँ से यहाँ तक बॉल आया, मैंने कैच कर लिया. सो दिस इज वन वे ऑफ ट्रांसफरिंग मैकेनिकल एनर्जी. नाउ जस्ट इमेजिन अनदर सीन. सपोज देयर इज अ ग्रुप ऑफ पीपल स्टैंडिंग वन बिहाइंड द अदर. यहाँ पर एक क्यू है, देयर इज this person is standing here, and then there is another person who is standing here. This is the second person, and then similar to him there is this third person who is standing here. So this is like, these all are people, and this person like who is in this, so what he thinks is like he pushes on to this person. So he is bit unruly, bit mischievous, थोड़ा सा शैतान है, इसने इसको धक्का दे दिया. तो जब इसने इस पर्सन को धक्का दिया है, तो आप देखिए क्या होगा, इसको सडनली पुश खा के ये हिट, ही लीन्स फॉरवर्ड एंड देन ही फॉल्स ऑन टू द नेक्स्ट पर्सन. So this first person, he pushes on to the next person, who on getting this push falls on to the next person, and then there is another person, you can say, there is another person who is standing next to this person, and then he also gets a push. So what happens is, once this last person pushes onto the next person, this person falls onto the next person, he receives this push, he falls onto the next person, and gradually this push is transferred to, let us say, another person who is some steps away from him. Let us say the first person in the queue. Now you can see that this person who transferred the push to this person has not gone anywhere. He just pushed and came back. The next person, he received the push and he fell, and then he again came back. And gradually this push got transferred to some person who is, let us say, standing here. So this push got transferred. So can I say that a push has traveled? A push has traveled from this person to this person, but this person is wherever he was, this person is wherever he was, this person is wherever he was, and then finally this person, he may, if there is no one, he can either fall down, or if he may be alert, he can also stand back. Now that is exactly what happens in a wave. I said wave is a travel of disturbance in a medium from one point to another without any bulk transport of matter. So this person, he hasn't left his place. This person, he hasn't left his place. This person, he hasn't left his place, but still we can say that this push has been transferred from one person to another. Same thing happens in a mechanical wave. So you have number of examples of mechanical waves. Waves in a string. When you plug the string, there may be waves in a string. Waves on the water surface. Now, often we think that water is flowing, but if water is flowing with the wave, again it is bulk transport of matter. So what simply happens is, like, just each particle is going up and down. There is no flow of water. Now, how can I prove this? So there is an experiment. When a wave is passing, like, just put a cork piece at any point, and as the wave comes here, you will see that this cork goes up and down. Then again wave comes, it goes up and down, it doesn't flow. So water is not flowing, each particle is just doing up and down, but this energy is transferred from one point to another. Sound waves, very important. I am speaking and you are listening. यहाँ पे थोड़ा सा complicated है क्योंकि my sound first goes to the phone, it gets recorded and then you hear it. But when you directly hear a sound, how do you hear it? Is anything traveling from my lips to your ears? No. Just I am creating a disturbance and that disturbance travels to the ears of the listener. All these are examples of mechanical waves. So two waves are very important. So in the first place, I didn't write the topic, but what we are studying is mechanical waves. I have illustrated what is the meaning of wave. Transfer of energy from one point to another without any bulk transport of matter. Now I am writing two important waves. First is waves on a string. Of course, string is a medium. So हम मीडियम में स्टडी कर रहे हैं, तो आप सोचेंगे दूसरी वेव्स कौन सी होती हैं? दूसरी वेव्स होती हैं इलेक्ट्रोमैग्नेटिक वेव्स, which do not need a medium, which can move from one point to another without a medium, and they travel with the speed of light. So we are not studying those. And second is sound waves. Now, what is the basic difference between these two waves is what I need to consider. तो मैं आपको बताना चाहता हूँ there are two kinds of waves. ये जो first kind of waves हैं, which I am calling waves on a string. So in this, like, what happens is, suppose wave is traveling in this direction, then particles are oscillating like this. And second is, the wave is traveling in this direction, but the particles are moving like this. ये थोड़ा सा आपको confusing फिर से लगेगा, तो इसको let me define it. What I mean here is, basically when wave is traveling, what happens is the push is transferred. अब इस Q वाले में देखिए आप, इसने इस पर्सन को धक्का दिया था ऐसे. So इस पर्सन का मोशन कैसे है? It's like this, forward and backward, forward and backward. This person moves forward and backward, forward and backward. So each person is moving forward and backward while the push is transferred in this direction. So you can compare it with this case, like each particle is moving like this and wave is also traveling in the same direction. This is called a longitudinal wave. So second one, which I have discussed first, is what we call as a longitudinal wave. तो दूसरा एग्जाम्पल ऐसा हो सकता है, जैसे सपोज यू आर होल्डिंग अ स्ट्रिंग which is stressed and you give a push like this. When you give a push like this, this particle goes up and down. Now you will be amazed what happens. Now since this particle goes up and down and this is connected to the next particle, so as soon as it starts coming up, it gives a push to the next particle, so it also starts coming up. So here something different happens. So it's like this person goes up and comes down, which happens in a drill sometimes. You stand up and get down. Next person is stands up, comes down, stands up, comes down. So here also, as it goes up, it pushes this person. This pushes next person. This pushes next person. But now each particle is doing motion in this direction while push is transferred in this direction. So you can see that motion of the particle is perpendicular. This is perpendicular to the direction of the motion of the wave. So this particular kind of wave which happens in a string is called a transverse wave. तो आप इसको इजीली इमेजिन कर सकते हो, पार्टिकल ऐसे हो रहे हैं, वेव ऐसे जा रही है, पार्टिकल ऐसे वाइब्रेट कर रहे हैं, वेव ऐसे जा रही है. So if the vibration of the particles is perpendicular to the direction of the wave, you call it as a transverse wave. If it is parallel to the direction of the wave, you call it as a longitudinal wave. तो ये छोटी सी दो इंपॉर्टेंट बातें हैं जिसको आप समझ सकते हैं. वेव क्या है? ट्रांसफर ऑफ एनर्जी, or you can say disturbance from one point to another without any bulk transport of matter. There are two kinds of mechanical waves, like this is a transverse wave, ये लिख देते हैं यहाँ पे हम, and this is a longitudinal wave. In transverse wave, the vibration of the particles is perpendicular to the direction of travel of the wave, and in longitudinal waves it is in the same direction. कुछ particles जो वाइब्रेट करते हैं, जैसे वाटर पार्टिकल्स, जब वेव जाती है वाटर से थोड़ी कॉम्प्लिकेटेड होती है, तो वहाँ पे वो 2D वेव होती है, मतलब वहाँ पे एक ऐसा कुछ भी मिलता है उनको और ऐसा भी मिलता है. सो पार्टिकल मूव्स इन सम पाथ एज द वेव पासिस. सो इट्स नॉट वेरी प्रिसाइसली a transverse or a longitudinal wave, but इस चैप्टर में whatever we are going to study is purely either transverse wave or longitudinal wave. तो आपको थोड़ा सा अगर लिखना है तो आप कह सकते हैं particles oscillate perpendicular to the direction of the wave, and here particles oscillate parallel to the डायरेक्शन ऑफ द वेव. तो आप नोट्स भी लेते जाइए, गो ऑन नोटिंग इट डाउन इन योर नोटबुक्स फॉर रेडी रेफरेंस, क्योंकि आप इसको बार बार नहीं देख पाओगे. सो इट्स वेरी क्लियर, लाइक व्हाट इज मैकेनिकल वेव विच नीड्स अ मीडियम, व्हाट इज द डेफिनेशन ऑफ वेव, एंड व्हाट आर टू स्पेशल काइंड्स ऑफ वेव्स लाइक ऑन अ स्ट्रिंग और द साउंड वेव्स. सो दिस इज अबाउट द थ्योरी ऑफ दिस. नाउ स्लोली वी आर गोइंग टू move to the mathematics of wave, like how do you write the wave equation. So that we'll deal in the next video. So much for now, see you in the next video. Just keep watching. This is the part 1. So this is the theory of what wave is. Next we'll discuss the mathematics. Thank you very much.